Welcome guys to today another lecture. Here we are going to do factorization by regrouping terms. Now I know that most people won't understand, but I will try to do the best as I can. Here on the board I am writing 2xy plus 2y plus 3x plus 3. Now, whenever you're doing an expression of this form, the factorization by grouping is to find similar variable that will match each of the term that you want to group. Here on the board, you see an expression containing 4 terms. So one of the way of solving this type of expression is by using the grouping method. Now first, how the grouping method work, you will group 2 of the terms together, then you will factor out the like terms for each, and then you will do the same for the following 2. Now, as you can see, 2xy and 2x contain both factor 2 and factor y, so you will have to place those outside. Now, the next two term, 3x plus 3, it contains the factor of 3. Let us go into it, guys. So first, what we're going to do is to write the factor for each of the terms. Now let us write the factor for 2xy. That yields 2 multiplied by x multiplied by y. And then we're going to write the factor for 2y after. Now the factor for 2y is 2 multiplied by y. That if we were to put 2 and y on the outside, we will get x plus 1 on the inside of the bracket. Now, if we were to group the 3x plus 3 and write in its factor form 3 multiplied by x plus 3, and if we were to factor out the 3, we will get 3 open bracket x plus 1. So what are we getting at? Let us do some erasing and then do some more. Now up to the top, we can clearly state that 2xy plus 2y plus 3x plus 3 can be factorized by using regrouping method, and the factors will be, for this we will have the 2y on the outside, x plus 1, and for this we'll have the 3 on the outside, x plus 1. And then these two terms, which is on the outside of the bracket, we can place those in one bracket by itself. Now, whenever you're doing factoring, whatever terms repeat, you can just write it back once. So therefore, 2xy plus 2y plus 3x plus 3 is 2y plus 3x plus 1. That is the factor for an expression of that form. Now there is something that I wanted to show you before I go further. Now, how do you know when you're on the right track? So what do you look for when you underwrite check? Whenever you are factorizing an expression of the form like 2x plus 2y plus 3x plus 3. Now, what you should look for is this. Whenever you factor out something, and take for example, you do the same by using the grouping method. Now, what you notice, these two brackets should always be the same. So, say for example, if you were to do it, and these brackets were to be different, then you have to make it remain as it is. But always remember, these two brackets should always be the same whenever you're doing a factorization with 4 terms using the grouping method. Now what I'm going to do this one more way. Now if you were to write the expression 2xy plus 2y plus 3x plus 3, and you were to rearrange it, put it all over the place, like, say, take for example, if you were to have it like this, right? So we are focusing on this. So we rearrange the equation to be in the form of 2xy plus 3x plus 2y plus 3. Now, if we were to do factorization by grouping, so we group these two terms together, and we were to write the common factor on the outside, which is x for this, we will end up with 2y plus 3, right? And if we were to write a common factor for this, on the outside we will have 1, 2y plus 3. Now look at this. So both brackets are the same, so we place x plus 1 in 1, and we write back only one of the like bracket. So this would be the factor for that equation. Now what am I getting at is this. Even if you were never to rearrange the equation and you were to factorize it just as how it is without rearranging it or regrouping it or whatever, you will get the same answer. But the thing is, if you were to rearrange it, it would be easier to solve than to solve it in the original form which it was given. Right? I don't know why I keep using it's crazy. I don't know why I keep using that one. But let us do some factorization, guys. So example number 1, let us factorize 6xy minus 4y plus 6 minus 9x. So with this, we're going to do it as it is, and then we're going to regroup it and see if we get the same factors. Now, as it is, we can simply factor out whatever can go into this and this. So we put 2 on the outside, right? So we have 2 on the outside, 2 into 3. Oh, I keep on doing that. I keep on saying the answer before. So 2 into 6 goes 3 times, you have that remained. Now the x is not common to both, but the y is. And we have minus 2 here, right? Then next what we will do is, from here, you know, we have minus 2, so we're going to find a number which can go into both 9 and 6, and that is 3. Now, tell me what you notice. You notice here, you have a positive 3x, right? But if you were to continue to do this as it is, you will have 2 minus 3x. Now, if you were to have something like this, what you can simply do is this. You have to manipulate the maths to get what you want sometimes. So what you're going to do is this. Here, you're going to change the sign to minus. And then here, right inside here, this will be minus, and then this will be plus. So with this be minus and this be plus, then the 2 brackets are the same. Yeah, you're gonna say, oh, it's minus 2 plus 3x. Look, it's minus 2 plus 3x. You can switch it. You can switch it if you want. You can make it look the exact way by doing this. Right? But if you do that, then you have to change this. But I want to do it to make it remain as how it is. But whosoever understands the maths will know that they are the same. So then furthermore, you can write 2y minus 3 and then write back only one of the like brackets. And then you will get the exact thing if you were to expand this to brackets. Now let us do this question again by doing the regrouping to see if it will yield the same answer. So I'm going to write out the question on the board. 6xy minus 4y plus 6 minus 9x. Now let us dissect this maths. So what we're going to do, we're going to put the x, 9x and the 6xy together. So we're going to have minus xy minus 9x. Then we're going to put this together. So we got minus 4y plus 6. Then we're going to factor out whatever common to both terms. Now, what is common to both terms are, for this we can write 3 on the outside on the x, and then whatever remained on the inside is 2y minus 3. And then for this, what we can factor out a 2, right? So let's factor out a minus 2, and if the minus 2 factor out, right, we're going to end up with, remember, now because the bracket is here, this minus sign belongs to the minus 4, right? So we factor out this, we end up with 2y minus 3. Now both brackets are the same, so we have 3x minus 2 and 2y minus 3. Now was that the same as before, guys? Look like it's the same as before to me. So that is how we do maths of this sort. Yeah. So let us go further into the wonderful world of maths. We are going to rearrange this same equation once more and see what we will get. So let us keep that there. Let us rearrange it one more time and let's see if regrouping is the good method as it says. So basically we are trying to prove to see if you rearrange these terms in this expression, you will get the same factor. Now let us do one more rearrangement. So let us rearrange this. If we rearrange this once more, so rearranging this, we can say 6xy plus 6 minus 4y minus 9x. And then from this, we can say what is common to both terms here. Remember, the minus is in that bracket. I'm going to put it in this time. So what is common to both terms here? So here, what is common to both terms are the 6's. So what we can do, we can either do one of both. And then by doing that, I want to see if we get the same answer. Now that is gonna be crazy because the same answer is not gonna be there. I'm telling you. I am telling you, if you were to factor out the 6, right? If you were to factor out the 6, you're gonna get 6xy. It's like getting I don't know, that's crazy. It's like you're gonna get 6, then you're gonna get xy. Then from here, you're gonna get the plus 1, right? And then you won't get the same thing there. So it's just crazy. So if we were to rearrange the question and keep rearranging it, then you will not get the proper fraction. You will not get the proper factor. My bad. Not fraction, factor. You will not get the proper fraction. So we bust the theory. So rearranging is not necessarily you flinging numbers where you think numbers should fling. Because if you were to continue to do this, I'm telling you, you're not gonna get the same result. So that's the myth buster on the rearranging. So you have to rearrange it so that it can satisfy the expression and the rule. Okay guys, so that's it for today's lecture. I want to do one more. So let's do one more. So here I'm going to write 2xy plus 3x plus 2y plus 3. So we're going to rearrange this all over the place and let us see if we will get what we want. So rearranging it, writing it 2xy plus 3 plus 3x plus 2y. So if we were to use this and then use this and factor what is common to both terms. Now look at it. What is common to this and what is common to this? What is common to this and this? 1, right? So if we were to have 1 and we have 2x plus 3, then what is common to this and this? We have 1 again. But the answer will not be the same. So that's why I'm saying be careful how you are rearranging these questions. Because the aim of the rearrangement is this. Because it makes no sense I am myth busting and I am not telling the conclusion. Now let us see what we conclude. We conclude that whenever you are rearranging it, just make sure that you're putting it according to where you can have one or more like term in both term, right? Or if you can have one or more like variable in both term, then you can say the rearrangement is proven correct, right? So if you were to factor out what is common to both terms here, which is x, then you will end up with 2y plus 3. And automatically you see this one fall into place. If you were to factor out a 1, you end up with 2y plus 3. So once again, what I've proven is that you have to make sure that whenever you are rearranging these expressions, you have to rearrange it according to the law that was stated earlier. Now look at this. Say we were to rearrange these 2xy plus 3, or not 2xy plus 3, 2xy plus 2y plus 3x plus 3, right? We know that this and this and this and this is common to both terms, right? And for this one, we have the x and we have the 3 common to both terms. So if we were to factorization by regrouping, which is this, that we already rearranged the expression to have 2 or more variables, being the same in each term, then we can go ahead and do the factorization. Now look at this. So we're going to factor what is common to both terms, which is the 2y, leave us with x plus 1. And for this, we're going to factor out the 3, leave us with x plus 1, my bad. X plus 1, right? Now we know that the two brackets are the same, so we put these, which is on the outside of each bracket, and only write back one of the line brackets. And this will give us the factor for the equation above. Now we have proven a lot of things today by explaining that if we were to rearrange or regroup the terms in the expression, if we were to do it the wrong way, we will end up with an unsolved solution. We'll end up with an unfinished solution. Now we have to, whenever we are rearranging these terms, we have to put it so that you have one or more variable in each of the terms that you're grouping, thus you can do the correct factorization. So guys, from here I am gonna jump into the quadratic